as we said, hey, we can compute these and look things up in a table and pull out our calculators or spreadsheet. But SigmaXL has a quick and easy way to get your confidence intervals both for the mean and the standard deviation, and it's in the graphical tool section. So under graphical tool, histogram and descriptive statistics, and we're going to get a little histogram together with all kinds of statistics that we can use to summarize the sample data set. So take your data, make sure you have it selected. We're going to go to descriptive statistics. We put our Y in the first dialog box and hit OK. So with very little effort, we get all of these nice statistics, and I highlighted the ones that we just covered. So we're not going to have to do very much computational work or look up in tables. We're going to get this all in one fell swoop. So it says, hey, the 95 confidence interval for your mean. So this is that same data, 4.2, 1.75. I took 10 samples. There's my computed low side and high side for the average, and then the same thing for the standard deviation. We also get things like the median, we get the range, and we even get a normality test. And here are the p-values above 0.05. So even though the data doesn't look super normal, it passes the normality test since we only got 10 samples. All right, so let's take a look at creating some of the charts and graphs from the die roll. So I will do the 25s here. Let me get it back up to the top. So I've got our die roll data set. Got SigmaXL open. I'm going to select my data here. It has my indicator and the rolls of the die. Just to keep the churning short, I'm going to pick the 25 at a time. So the way I created the graph is I first went in here to SigmaXL and then statistical tools. So I'm going to get means for each group in one big column, and then I'll make a histogram of that column. So I'm going to use descriptive statistics, and yes, I have all my data. Roll is going to be my Y, then I'm going to pick the 25s just to keep the churning down. And this is kind of a nice feature that SigmaXL has. Since I'm going to get a whole bunch of groups of 25, looks like 200 of them, I'm going to put them all in a column. That way I can graph straight down that column. All right, and then I'm going to hit OK, and it's going to think for a little bit. That wasn't too bad. So here I've got my means for all of those different samples, and I think I have 200 of them. Yeah. So now I'm just going to graph the means here. So I'll just grab that, and we'll do the histogram with the descriptive statistics. So I'm going to go into graphical tools, histogram and descriptive statistics. All right, I grabbed the data that I wanted. That's going to be my Y, and that's all we got to do. Alright, so there's my graph of the means of a roll of die taking 25 rolls at a time, and here are the computed means and the frequency of those computed means across my scale. We know that the exact answer is 3.5 based on math. We get pretty close, and we get our confidence intervals for the mean, confidence intervals for the standard deviation. Even says the data's normal, we get a p-value above 0.05. So that's how we create the graphs that we used in this section. And I'll just go back that you can use any type of data here, but as you group it, you're going to find that even very non-normal data, like the uniform in my rolls of the die, will give you this nice normal looking distribution of means or X bars. At this point, we've explored sampling error associated with estimating the mean and estimating the variance or standard deviation. But any parameter that we might estimate from data has a corresponding sampling distribution, and a couple of the others that we will use based on some of the hypothesis tests that we are going to conduct would be similar to the chi-square. We're going to look at ratios of variances. So we're going to take one variance, divide it by the other. That follows what's called an F distribution. We'll show you a picture on the next page. And then proportions, those follow a binomial distribution. So if I have a 80% pass or 20% fail, whichever way I want to say that, I can compute the accuracy of my proportion based on, again, my sample size and the binomial distribution. So in all cases, you'll see that by increasing the sample size, my sampling error gets smaller.